Okay, you guys, so we are on section 1.1.4, which is points of intersection and multiple representations. And what we're going to be doing today is figuring out how to solve a system of equations, in other words, find the intersections in 3 different ways. So you do need your graphing calculator out, and this is meant to be done before the section in the book. So the first thing that you want to do is go ahead and type in those 2 equations into your graphing calculator by going to the y equals button. Remember that they always have to be in y equals form, so if you had something like negative 2x plus y equals 1, you would need to move it over so it's y equals positive 2x plus 1. Alright, we are going to go ahead and graph it. So what we did in class on Monday and Tuesday is we learned about this trace button. So I'm going to go ahead and click that, and you'll see that we can kind of estimate the intersections. So it looks like it's probably 1, 3, right? The other one looks like it's up here, but unfortunately we can't see it, but there's a way to fix that. So remember, you go to Window, and it looks like we need more y value. So I'm going to go ahead and change the y max to like 15. And we'll see if that works. My windows are set on the standard window, which is negative 10 to 10 and negative 10 to 10. So I just changed my y max to 15. And so let's see if we are able to see it better. And we can. Okay, so again, if I were to estimate, I would say, you know, it's about 1, 3, and maybe 6, 13, right? But that's just an estimation. It probably is that, but we don't know for sure. So there is a way to get an exact value, and you're going to do that by using the calculate button. So to do that, you go to second, and then you're going to click trace, which is calculate, and then you can scroll down to intersect, or you could actually just push the number 5. Okay, select that. Then what you're going to do, this is kind of a weird process, but you actually want to put the cursor near one of the intersections, so that way it knows which one to find. So mine's already over here, okay? Then from there, you're going to click enter 3 times. So 1, 2, 3, and then at the bottom, it shows us that the intersection is 6, 13. Okay, so that's one of them, so we'll go ahead and write that down. But we still need to find the other intersection. So we're going to go ahead and do the same process again. So second trace, this time I'm just going to hit the number 5, which will take me to intersect. And remember, I'm going to move this cursor over to find the other intersection so it doesn't find the same one again. Then I'm going to click enter 3 times. Enter, enter, enter. And we have the other intersection, which is 1, 3. Okay, so that is the first way to solve a system of equations using a graphing calculator. So again, what we did was we put both equations in the graphing calculator, and from there we calculated the intersection by clicking second trace, selecting number 5, which is intersect. You move the cursor towards one of the intersection points, and then you click enter 3 times. If you have another intersection, you're going to repeat that process again. All right, there's actually a second way we could use our graphing calculator to figure out the intersection, and that's using the table feature. So you're going to go to second, and you're going to click graph, which will take us to the table. So what you can do is you're going to kind of go through here, and what you're trying to find is when you have an x value that has the same 2 y values. So if I go through here, we kind of already know, right? So it's not very exciting, but when you see this x value 1, you can see that both of the y values are 3, so that would be an intersection point. And so at 6, both of the y values are 13, so that would also be an intersection point. So yay, we're done. So again, this is the table, so to get to it, you go to second graph, and then you look at when an x value has the same 2 y values, that means that they are the same point, and that's where they cross. The last way is to solve it algebraically, so I'm going to go ahead and do that. So I'm going to use substitution, so I'm just going to set these 2 equal to each other because they're both equal to y. Now, in your classwork, you are going to have 2 parabolas, so it's going to be the same process, but you're going to just move both parabolas. Obviously, you'll start off like this, but then you want to move like maybe this over to the other side so that you have it all on one side. So I'm going to go ahead and subtract 2x from both sides. Sorry for the shakiness, but this is the only way I could figure out how to do it because I'm filming the calculator, so I'm just using paper. So then we would have x squared minus 7x, and then we have plus 7 equals 1. So then I'm going to subtract 1. So what I'm trying to do is move everything over to one side, so then that way we have it in standard form. So then you have a quadratic, and then from there you can solve it using any method. I prefer factoring. So we need two numbers that multiply to 6, but add to -7, and that would be -6 and -1. And so we can use the zero product property to know that these answers would be 6 and 1. And then from there, you can plug these into either equation to get your y values. So I'm going to choose the linear one, so 2 times 6 plus 1, which is 12 plus 1. So that means our point is 6, 13. And then over here, 2 times 1 plus 1, so that's 2 plus 1, which is 3. So our other point would be 1, 3. So what we did was we learned 3 different ways to solve a system of equations, 2 with the graphing calculator and 1 algebraically.